Hi, welcome to Levelfield channel again. In our previous video, we talked about how to build reading skills in children. Today, I'm going to talk a little bit about math skills. Now, for the junior classes, let's say when a kid is at the age of 5, 6, 7, in class 1, 2, in those classes, the key math skills initially are the four operations: addition, subtraction, multiplication, division. Kids need to learn to do those and be very comfortable in those. Now, what happens is that these things require a lot of practice. How do you learn to be fluent in addition, fluent in subtraction? Because it requires a lot of practice. Now, if kids keep on doing additions like 45 plus 27, or divisions like 847 by 23, the way to learn addition, subtraction, multiplication, division is to be doing a lot of sums like that, but those sums can get very boring and repetitive, and that can kill the interest in mathematics. So what we do in level field, we take a very different approach. We obviously have to get kids to practice these four operations: addition, subtraction, multiplication, division, but we also blend in a lot of variety, a lot of thinking and logic in it. So what we do is that around these four operations, we build a huge number of different activities, a variety of activities, which solving each one of these require obviously application of addition, subtraction, multiplication, division, but also a lot of thinking and logic, so that the sums do not get boring for them. At the same time, they're building their calculation skills as well as thinking orientation. Let me show you some examples of things like that. The first thing that I'm going to show you is something called multiplication kakuro. So this is something students do after they have learned multiplication tables and a little bit of division. Here I am showing you a solved example of a multiplication kakuro. Okay. Now it's a Sudoku type of grid, and in each of the cells only single digit numbers can come. And just like a Sudoku, numbers cannot repeat in a row or column. Okay. So what happens is that in the dark boxes there are the clue numbers. So you see this clue number 8, and below 8 there is 4 and 2. So 4 into 2 is 8. So that is the way this 8 was solved. Okay. 144, here you see 144 is 8 into 9 into 2. 28 is 4 into 7. 32 is 8 into 4. So these numbers have to be filled in such a way that both in rows and columns, up, down, or sideways, the numbers when multiplied gives a clue number. Okay, here also we are saying 24 is 6 into 4. So how that you can clearly see that how that this might use the skill of multiplication and division, but how it might also use a lot of thinking. Let's see that by trying to solve one ourselves. So we go to this unsolved multiplication kakuro, and we see here this number 27, which has to be gotten by multiplying two numbers. Clearly it cannot be 1 into 27 because we are looking for two single digit numbers. So it has to be 9 into 3. So you can see that this also includes a little bit of factoring skills. So 9 into 3. Now, can we put 9 here and 3 here? There lies a little bit of thinking, right? Because if we put 9 here, then in this side, sideways we have to get 24. 24 is what into 9? Nothing into 9. 24 is not divisible by 9. So 9 cannot come here. 3 has to come here and 9 here. So the kid, as he is doing it, he has to continuously think through it. Which cell I can solve first? Which number I can put in that cell so that the future things become solvable? Okay, so we got 3 here. Now 24 becomes solvable. 24 is 3 to 8. Now let's go to this 9 below. 9 can be 1 into 9 or 3 into 3. But because it's a Sudoku style thing where two numbers cannot repeat, the same number cannot repeat. So 3 into 3 is not possible, 1 into 9. Now, can we put 1 here and 9 here? Again, we cannot, because this 56 has to be a multiplication of three numbers, which one of which cannot clearly be 9, because 9 into nothing is 56. Secondly, if this number is 1, then this number has to be 45, so that goes beyond single digit. That is also not possible. So because of various logic, this has to be 9 into 1. So as you can see that not only it requires multiplication division, it also requires a constant thinking. Now again, this number 45, already we got 9, so we know that we can solve it now. Understanding what we can solve also requires a little bit of thinking, right? So 45 is 5 into 9. Now you got all of this. Only the middle number is remaining. 56. 56 is 8 into 1 into what? Clearly 7. Now the last one that was also remaining, 315, that is 5 into 7 into 9. You can check that also works. So both sides, sideways and up down, all the numbers when multiplied leads to the clue numbers. So that was what was multiplication Kakuru. Let me submit it. Yes, it is correct. So as you can see that this required multiplication, division, little bit of factoring, a lot of thinking. And as opposed to asking the kids to continuously write down multiplication tables or do a lot of boring long divisions, long multiplications. As opposed to that, this is also a fun activity. So as a result, kids are interested and it provides a lot of variety and a lot of thinking. This is not the only app that we have which are related to multiplication division. This is just, as I say, the tip of the iceberg. We have hundreds of apps for the primary level where kids are working on these four operations, but not directly, but in a thinking oriented way. Now let's look at another one where we are looking at addition subtraction. So this is an app called Magic Square, where there are 3 rows and 3 columns. Now each of the rows have to add up to the big number that's here. Okay, and each of the columns also have to add up to the big clue number that is here. The numbers that are in black font, they were already there, and so this is solved Magic Square. And numbers that are in gray font, that were put in the process of solving. So what you can see is that 8 plus 3 plus 2 is 13. 1 plus 1 plus 11 is 13. 4 plus 9 plus 0 is 13. Similarly, 2 plus 11 plus 0 is 13. So all rows and columns add up to 13. Now, let's see how it aids both doing of addition, subtraction, and also blend in a little bit of thinking. Let's try to solve a Magic Square ourselves. Okay, here the clue number, as you can see, is 22. All the numbers have to, all the rows and columns have to add up to 22. Okay, so first thing that is required, first bit of thinking that's required here is to understand that which one we can solve first, which cell we can solve first. Can we solve this one? We cannot, because here we can only solve things where we know that 3 numbers will add up to 22. So if 2 numbers are there, we can find a third number. But in this column, clearly 2 numbers are not there. So we cannot with certainty say what will come here. Let's look at the first row where 2 numbers are already there. So we got 10 plus 2, 12. We have to go up to 22. So we did an addition, 10 plus 2. Now we have to do a subtraction, 22 minus 12. 22 minus 12 is what? 10. So here 10 comes. So 3 numbers now add up to 22. Now that we have solved this number, this cell has become solvable because we got 2 numbers here. What is the addition of these 2 numbers? 10 plus 9, 19. And now how much more to get to 22? There a little bit of subtraction is required. So 3. Now we can see that we can solve either this or this, but not this. Okay, again, a little bit of thinking is required to understand which ones we can solve. Now, if we solve this, we got 2 plus 4, 6, a little bit of addition, and 6 plus what is 22? So put 16 here, 6 plus 16 is 22. Now, this 9 and 4, here also two numbers are present. So we put in the third number, 9 plus 4, 13. Another 9 will make it 22. And now only the middle cell is remaining, where we got 10 plus 9, 19. This side also we got 3 plus 16, 19. So only 3 is required to solve the middle one. Submit it and it turns out to be correct. So this was Magic Square, which is again one of the many apps which gives children practice in addition subtraction, but in a fun way, in a thinking oriented way. We have a huge number of these apps which focus on addition, subtraction, number concept, multiplication, divisions, none of which are straightforward mechanical way of doing addition, subtraction, multiplication, division. So they all employ a little bit of thinking, a little twisted way they present the question. And as you understand that in each of these questions, like in a Sudoku, each time you solve a Sudoku, you have to think afresh. Okay, just because you know the rules of Sudoku does not mean that in your next Sudoku, after you have solved one, you do not need to think. Similarly, in that multiplication Kakuro or this Magic Square, obviously you know the rules, you have solved one. That doesn't mean next time you do not have to think. So each time it gives them thinking practice. So not only these two things, I'm just showing you some examples. So we have a lot of activities, all of which have been algorithmized and built into apps so that they can get unlimited practice in not just calculation but also in thinking. Now let's look at something which is pure thinking, which does not involve any addition, subtraction, multiplication, division, pure thinking and logic. So actually Japanese have a lot of puzzle like that. We also employ several of them. One of them is something called nonogram. Okay, so let's look at that. Again, first thing that we show you is a solved nonogram so that it becomes apparent for you what are the rules of this particular activity. So on top of the columns and on the side of the rows, there are the clue numbers. Now the clue numbers denote how many cells below are shaded. Now here 3, 1 is written. 3, 1 means that a block of 3, as you can see, and then one cell is shaded. 3, 1 also means that there must be a gap between the block of 3 and that single cell. However, this 4 that you can see, 4 means a continuous block of 4 is shaded. Okay, here a continuous block of 4 is shaded. Here also a continuous block of 4 is shaded. 1, 1. That means one cell and one cell are shaded, but there must be a gap between them. So here one cell, there is a gap. There could be two gaps also sometimes. Here, as we can see, that here 1, 1. Here one cell shaded, in the middle there is gap. So there has to be at least one gap, there could be more. So you have to fill in or shade the cells in such a way that both the row clues and column clues satisfy. Okay, so this requires obviously a lot of thinking, a lot of Sudoku style thinking. Now let's try to solve one ourselves. Okay, here let's look at this 4. Okay, now this 4 can be this. That means the cell number 1, 2, 3, 4, or it can be cell number 2, 3, 4 and 5. But no matter what happens, we know that cell number 2, 3, 4 must be shaded for 4 to happen, right? Similarly for this 4 also, cell number 2, 3, 4 must be shaded. So there it required quite a bit of thinking, right? You might think it's a little trivial because in the adult mind, this sort of thinking probably can come somewhat automatically, but for a kid for whom it is directed, age 6 or 7 kid, for them it's a lot of thinking. Now let's look at 3 1. How can we make 3 1? Clearly there is only one way of making it, because there is 3, and if you have to keep one gap and then 1, then all the 5 cells get filled. So 3 1, 3 with one gap and then 1. Now let's look at another bit of logic. Here you have 3. Now you got 2 here. 3 can be either this one or this one, but it can never be this one. So we shade it white. Okay. That gives us some clue about what will be this 1 2. 1 2 has to appear with a gap. Obviously it cannot be both on this side, right? So the 2 has to be here and 1 has to be one of these. We don't know which one yet, right? Now let's look at this 1 3, which is quite straightforward. 1, then with a gap, and then 3, which means that we have solved this 4, which means this then becomes white. Here 2, 1 we have already got, so 2 cannot be here because then it becomes 1 1. So 2 cannot also be here because this is already a confirmed white. So 2 is here. So as you can see, each step there's a little bit of logic involved, and that sharpens the brain of the kids. So here white and here also white. Here you got 3. It starts from here, so it has to go only this way, and this one has to be white. Now we got the 4 also, and as a result we also solve this 1 2. Now 2 1, this 2 already we got, so there has to be a gap now, and this 1. Now all of this is solved, and both the row clues and column clues both are completely satisfied, and submit this, and it is correct. So as you can see that what we are trying to do at Level Field is to give the kids a lot of thinking practice every day. Thinking practice sometimes along with arithmetic calculation practice when they grow up a little bit, then along with algebra, a lot of thinking practice. None of the sums that we give to them is just pure boring routine mechanical addition subtraction or mechanical algebraic calculation. Okay, because if you practice too many of those, then you are just doing routine mechanical stuff. As a result, that sort of practice does not make you perfect, but it numbs your mind, makes you dumb. So the 3 apps that I showed you, 3 activities that I showed you, these are really a very minor fraction of the entire repository of apps that we have. We have hundreds of apps for primary level, hundreds of apps for middle school and senior level, and obviously hundreds are required because even these you cannot give them in too much quantity, right? Then this might also become routine. So this also comes to them in a mixed format. First time maybe multiplication calculo comes, and then a magic square, then a nonogram, then something else. So that continuously being challenged, that's what hones their skills, and that's what gives the Level Field School its great results. As you know that in various exams, be it SAT, where our school students' median score is 1550, in all India based IPM examinations for integrated programming management in IIMs, our students routinely come in the top 50 all India rank. So that's because they have very strong thinking orientation. They can look at a new problem and can solve it because the thinking orientation is honed right from class 1. So these apps now are not only available for students of Level Field, but we are also very soon making it available on a subscription basis to all people externally. So that's it today. If you like our channel, subscribe and like this video. Thank you for watching.